Welcome back, Apologia 8th grade Physical Science, week 10, day 4, textbook pages 161 to 165, notebook pages 127 to 128. Experiment 5.1 will be done in class. Okay. Now that we can name compounds and write formulas, we can use that information to learn about reactions. You already know how to determine if reaction is taking place. Think back to Module 2. Whenever there is a sign of a chemical change, there is a chemical reaction taking place where new products are being produced. Scientists classify chemical reactions because knowing the type of reaction helps to predict the products of the reaction. And there are some common categories. They are usually classified by the type of reactant or number of reactants and products. Chemical reactions can be generally classified as synthesis, decomposition, single replacement, double replacement, and combustion. Each classification describes a different way in which reactants interact to form products. So let's dive into synthesis. A synthesis reaction is any reaction in which a single compound is formed from the combination of two or more elements or compounds. So the actual definition is a chemical reaction in which two or more substances react to form a single compound. And here we have A plus B yields AB. That is the general equation for a synthesis reaction. Many elements combine directly with each other or with another compound to form a single product. The product is always a single compound. Look at the flask in figure 5.6. A sample of sodium metal was dropped into a flask containing chlorine gas. What you see in that figure is what happens when sodium reacts with chlorine. How can you tell a chemical reaction is taking place? The bubbles, like we talked about, this should give it away right here, and some kind of a shiny light. Notice the cloudy substance spewing out of the top of the flask and the release of energy, which is the light shining in the bottom of the flask. These are both signs that a chemical reaction is taking place. At the end of this reaction, the product will be the compound sodium chloride, which appears as a whitish solid crystal, again, table salt. The reaction for the synthesis of sodium chloride can be described with the following equation. We have sodium plus chlorine gas yields sodium chloride. Another example of a synthesis reaction is when the compound nitrogen monoxide combines directly with oxygen gas. Again, nitrogen monoxide, one nitrogen, one oxide, plus oxygen gas. It's a diatomic element, so plus O2 yields nitrogen dioxide. Notice the nitrogen monoxide is a compound, but when it reacts with oxygen gas, it forms a different compound with different physical characteristics. Nitrogen monoxide is a colorless gas. Nitrogen dioxide is a reddish-brown gas with a strong odor. Because there are two reactants, even though one is a compound, that join to form one new product, this qualifies as a synthesis reaction. Decomposition. Has your mom or dad ever used hydrogen peroxide on your scraper cut? Did you ever notice that the bottle of hydrogen peroxide is always a dark brown, opaque brown? Have you wondered why? The reason that hydrogen peroxide is always kept in this type of bottle is that hydrogen peroxide must be protected from light. If it isn't, the energy from light will be used to gradually break down hydrogen peroxide, which is H2O2. Down into water and oxygen. So this is a decomposition reaction. And the definition is a chemical reaction in which a compound breaks down into two or more simpler substances. Decomposition reactions are the opposite of synthesis reactions. In decomposition reactions, a compound, the reactant, breaks down into two or more simpler substances. The products, remember the products are over here and the reactants over here. The products may be elements or different compounds. The reactant compound is decomposed when a form of energy, such as light, heat, or electricity is added. In the hydrogen peroxide example, the energy is simply light energy. The following chemical equation describes the decomposition of hydrogen peroxide. We have 2H2O2 yielding water plus oxygen gas. Let's go back real quick. This is the general equation for decomposition reactions. We have AB, the reactant, yielding the products A plus B. Another example of decomposition occurs when electricity passes through water. The energy provided by the electricity causes the water to decompose into hydrogen gas and oxygen gas, and this product is actually called water electrolysis. The following chemical reaction describes the decomposition of water. We will be completing experiment 5.1 to actually decompose water in class on the 29th.